Bayesian decision theory, utility theory. In equation 3.7, we defined the expected risk and choose the action that minimizes expected risk. We now generalize this to utility theory, which is concerned with making rational decisions when we are uncertain about the state. Let us say that given evidence X, the probability of state Sk is calculated as the probability of Sk conditioning on X. We define a utility function uik, which measures how good it is to take action alpha I when the state is Sk. The expected utility is EU of alpha I conditional on X is equals to the summations of uik times the probability of Sk conditioning on X, where the summation is summing for all index k. And a rational decision maker chooses the action that maximizes the expected utility. That is, we choose alpha I if EU of alpha I conditional on X is equals to the maxima taken among all possible EU of alpha j conditional on X, where the maxima is taken among all possible j. In the context of classification, decisions correspond to choosing one of the classes, and maximizing the expected utility is equivalent to minimizing expected risk. UIK are generally measured in monetary terms, and this gives us a way to define the loss matrix lambda ik as well. For example, in defining a reject option, equation 3.10, if we know how much money we will gain as a result of a correct decision, how much money we will lose on a wrong decision, and how costly it is to defer the decision to a human expert. Depending on the particular application we have, we can fill in the correct values UIK in a currency unit instead of 0, lambda, and 1, and make our decision so as to maximize expected earnings. Note that maximizing expected utility is just one possibility. One may define other types of rational behavior, for example, minimizing the worst possible loss. In the case of reject, we are choosing between the automatic decision made by the computer program and human decision that is costlier, but assumed to have a higher probability of being correct. Similarly, one can imagine a cascade of multiple automatic decision makers, which, as we proceed, are costlier but have a higher chance of being correct. We are going to discuss such cascades in Chapter 17, where we talk about combining multiple learners.